This is October, November 2021. 2021 P42. The very first question that they've given is a very good question in terms of circular motion. So in this paper, I will explain the circular mechanics of this situation, the example in which there's a trolley car, and also an example, the exact example fits on a person who is holding a bucket of water and is rotating above its head. Why doesn't the water fall out? So that is also exactly the same question. This is what is meant by centripetal acceleration. So the acceleration being perpendicular to the velocity is the centripetal acceleration. Concerned marking scheme to memorize the answer. All right. So the mass is given, the diameter is given. And of course, first the car exists at this point, then the car may exist, or at some point later in life will exist at this point. Okay. And then of course, come down to continue its journey towards that side. We understand this, okay? So the mass is given, everything is given. He says, state what happens to the magnitude of centripetal acceleration of the car as it moves around the loop from X to Y. So it decreases. And why this is happening, we will get to that later. So then he's explained why, if the car remains in contact with the track, why the centripetal acceleration of the car at point Y must be greater than 9.81 at least. So the reason is that the centripetal force is actually the resultant of the normal reaction and the weight at any time or at any point in time. Okay, so the centripetal acceleration has to at least minimum compensate the weight of the trolley, which acceleration is mg, of course, right? It needs to compensate for that at least, so that there can be some normal reaction, some contact maintained with the ground with the force. Okay, so centripetal force needs to be greater than the normal reaction, hence centripetal or centripetal acceleration should be greater than 9.8 at least. Let's go a bit deeper in each of these cases so that we can understand what we are discussing it in terms of theory. You see, first we need to establish that the centripetal force is the resultant of two cases. First we need to establish this. So the resultant force Fr equals to Ma. This is a centripetal force and this is the resultant force. In our situation, let that be in any case, weight is being, or the resultant is being found by using weight and normal reaction, sometimes plus, sometimes negative. We'll get to that later. Okay. And then we have mass into acceleration. So Ma. Now let's look at it in terms of the circular motion. So when it is at point X, the weight is downwards, the normal reaction is upwards, and in this case, most definitely, both are actually in the opposite direction, right? So normal reaction at the bottom, at this case, normal reaction should be greater than the weight. Only then the resultant will be in this direction, causing centripetal acceleration, right? So this will be nr minus w equals to mv square over r. Okay. So the normal reaction actually becomes equal to not only the centripetal force, which is mv square over r, plus also the weight. So at the lower point, the normal reaction is going to be very high, or is going to be higher than the top point. So this is what happens at the bottom at least. This is the bottom mechanics. Now let's go to the top. The weight is also downwards. The normal reaction from the surface is also downwards. They're both in the same direction. And the resultant is going to produce a centripetal acceleration. So since according to F equals to ma, in this case, both are going to add it together. So W plus the normal reaction equals to mv square over r. Now, since we are interested to find the normal reaction, because this is what changes, weight remains the same, that is mg, and centripetal acceleration is because of the resultant. So let's make normal reaction the subject of the formula. So that becomes mv square over r minus the weight. So at top case, the normal reaction slightly reduces because the weight is being subtracted. And at the bottom case, it slightly increases because weight is being added into the system. Okay. So this is why we are getting these answers. That when it goes from X to Y, when it goes to the top part, the whole answer is becoming smaller, so the centripetal acceleration will be smaller. Okay, all right. And the same answer can be, same idea can be used to explain this part too as well. Let's move to the next question. He says we need to show whether the car is in contact at point Y or not. First, we need to find out the velocity at point Y. What will be the velocity at point Y? So the height change from this point to this point is actually 62 centimeters, right? So if it has a certain velocity moving at this point, when it goes to this height, it will lose kinetic energy and convert this into gravitational potential. So there will be a fall in velocity. So we can use simple equation of motion, either use it in terms of energy, right? Energy calculations, or you can do this in terms of kinematics as well, that V square equals to U square plus 2 into negative 9.81 because it's moving against gravity, and then 62 into 10 raised to power minus 2 to convert this into meters, right? So this is our initial velocity, which was given to us as 3.8 square. So when you take the under root over the other side, and of course this is going to subtract from this value, so this comes out as 1.51 meters per second. So when the object is at the location Y, it must be moving at 1.51 meters per second. Now let's go back to the equation at the top. What's happening at the top? You see, normal reaction, if he says that it maintains a contact, for example, that the car is in contact or not, normal reaction may become 0 or should be greater than 0, at least should be greater than 0. So let's rewrite the equation for the top part again. So when the trolley is at the top, the normal reaction is equal to the centripetal force minus the weight of the object. So let's say normal reaction equals to mv square over r minus mg. Now, generally speaking, this is what we're looking at, right? And this is what we have to calculate, and we understand that this whole system should be greater than 0. This is one way of justifying the answer, right? The other way is going to be in terms of acceleration, which he uses. But let's look at it from the perspective of forces, right? So I say that the normal reaction should be greater than 0 to maintain contact. But is that the case? We're going to check this whether that is the case or not by using the equation. Normal reaction is equal to or greater than equals to at least mv square over r minus mg. So we suspect it should be greater than 0. It needs to exist. उसकी कोई ना कोई value होनी चाहिए, तभी वो greater than 0 होगा. तो हम इन values को calculate कर लेते हैं. So this is, let's calculate this whole scenario on the side. So nr being greater than what? So mg, that is 230 divided by 1000 divided by 9.81 into velocity square at y, which is 1.51 square divided by जो radius था इसका, that will be 0.31 at that part, right? Radius of the acceleration or the circular motion minus the weight, which is 230 divided by 1000, right? Divided by 9.81, right? Multiplied by 9.81. So when you're done with this, sorry, this will not be divided by 9.81. This is just divided by 1000. To convert this grams into kg. So this is mg. So this is mg. And this is mv square over r. Notice that it should be greater than 1 point. It should be greater than 0. So we find that this answer comes out as 1.669 newtons. This comes out as 2.563 newtons. And we said that normal reaction should be greater than 0. It should be greater than 0. Is it coming out greater than 0? So when you subtract this, this comes out as negative 0.894 newtons. This is not equal to 0. This is not greater than 0, which means that the normal reaction does not exist, which means that the trolley is not in contact. The trolley is not in contact. Otherwise, normal reaction would have been greater than 0, or it would have been participating at least in contact with the trolley. Now, another way to justify this same situation, same scenario, is in terms of gravitational acceleration. You see, the whole system actually became normal reaction plus weight equals to the centripetal force. This was happening at the top because they're in the same direction. And we want to find it for the normal reaction, right? So in normal case, we know that mg is equal to the normal reaction, which is mg as well. But for the sake of understanding, we're going to write this down as ma. So ma, resultant acceleration, okay, minus mg plus mg equals to mv square over r. Now we realize that mass is same, so it cancels out from the whole equation. So what we are left with is simple normal acceleration or centripetal acceleration. Sorry, the acceleration provided by the normal reaction plus the gravitational attraction equals to the centripetal acceleration, which is v square by r. Let's take this over there, and we realize that the centripetal acceleration, circular acceleration by normal reaction is equal to centripetal force or centripetal acceleration minus the gravitational attraction. So if we want this number to be at least 0 or greater than 0, right? We understand that this is supposed to be greater than 0. Then this equation is supposed to go something like this: v square over r minus g. So when that goes over there, this means that g is less than and v square over r, this should be greater than this. So our final answer should have been greater than 9.81 meters per second square. Let's calculate the centripetal acceleration. Is it greater than 9.81 or not? Let's verify this. So to verify this, we will use v square over r. This becomes 1.51 whole square divided by r, which is 0.31. When you finally calculate this, you realize that this is going to come out as 7.25. So 7.25 meters per second square. What did we need? हमें क्या चाहिए था? हमें चाहिए था कि इसकी gravitational acceleration 9.81 से ज़्यादा होनी चाहिए थी, या 9.81 से सेंटीमीटर ज़्यादा होता, बट सेंटीमीटर तो 7.25 है. अगर ये कम है तो इसका मतलब है नॉर्मल रिएक्शन एग्जिस्ट नहीं करता. या आप ये सोच सकते हो कि 7.25 जो है वो जिम्मेदारी ले ली सेंट्रीपिटल फोर्स ने, बाकी का कौन शेयर लेगा ताकि ये 9.8 बने? तो बाकी का शेयर नॉर्मल रिएक्शन की जिम्मेदारी थी, जो कि हम उसको नहीं दे सके. तो जिससे प्रूफ ये हो गया, साबित ये हो गया कि नॉर्मल रिएक्शन एग्जिस्ट नहीं करता और ये चीज़ कांटेक्ट में नहीं है. ठीक है, तो हमने उसको फोर्सेस से भी बैलेंस करने की कोशिश की है और हमने उसको एक्सेलरेशन से भी देखने की कोशिश की है. व्हाटएवर मेथड सूट्स यू, आप उसको अडॉप्ट कर सकते हैं. सो मूविंग ऑन टू द नेक्स्ट पार्ट, सजेस्ट व्हाई बट विदाउट कैलकुलेशन वेदर सी वुड बी एप्लीकेबल फॉर 460 और नॉट. देखिए, इफ यू ऑब्जर्व इट फ्रॉम इन टर्म्स ऑफ एक्सेलरेशन, मैथ्स तो पूरी इक्वेशन में से कट हो जाता है. और अगर आप यहाँ पर भी इन टर्म्स ऑफ मैथ्स ले भी लेते तो मैथ्स इधर भी है, मैथ्स इधर भी है, रिजल्टेंट इफेक्ट तो आंसर तो यही आ जाना था दोबारा. ठीक है, क्योंकि मल्टीप्लिसिटी में ये भी बड़ा हो जाता, ये भी बड़ा हो जाता, बट क्योंकि लीनियर इक्वेशन है तो दोबारा इनके डिफरेंस का आंसर यही आना था. हालांकि ये भी आंसर बड़ा आता, ये भी बड़ा था, लेकिन आंसर डिफरेंस का यही आ जाना था दोबारा. So there is no difference. In terms of acceleration, it's easy to visualize because we can see that mass is cancelling out. And in terms of forces, उसको थोड़ा सा explore करना पड़ता. So I hope that we understand this top and bottom case. Please be very careful. This question I've seen that is getting repeated again and again in past papers. So next question is about state relationship between gravitational field strength and gravitational potential. You can write this down in English yourself. I'm just going to explain the mathematics of it. So gravitational potential and field strength. If I write down the equation for both of them, that will be gm over r square, and potential is equal to gm over r. So what is the difference between them? If I take the derivative, for example, of the g with respect to the radius r, I get the formula for potential. So if I were to observe the gradient of g with respect to r, then I would have gotten the gradient, or I would have gotten the function of phi. So that is what he's mentioning in the question. That is what he's mentioning in the marking scheme, that g, or you can say that the potential, the gravitational potential is actually the gradient of gravitational field strength. अगर आप इसका gradient निकालेंगे by derivation mathematics की, तो आपके पास potential आ जाता है. इलेक्ट्रिक पोटेंशियल में भी यही होता है. ठीक है, कि आपके पास जो इलेक्ट्रिक फील्ड स्ट्रेंथ होती है उसका अगर आप ग्रेडियंट निकालो तो वो हमारे पास एक इक्वेशन बन जाती है v by d. तो वोल्टेज की हमारे पास जो E की इक्वेशन होती है वो हमारे पास होती है q by 4 pi epsilon naught r square equals to v by d. d r ही होता है, एक r कट जाता है तो वोल्टेज की इक्वेशन आ जाती है एज q by 4 pi epsilon naught r. तो इलेक्ट्रिक फील्ड का आप वोल्टेज से ग्रेडियंट लेंगे तो इलेक्ट्रिक फील्ड आ जाएगी. सेम चीज यहाँ पे हो रही है. ठीक है, ओके. So let's move on to the question. M is given, R is given. Okay, 3m or 2r, everything is given in terms of variables. This is a graph for potential for planet number 1 and planet number 2. You find why phi is negative through ray. Now again, this question has been repeated again and again. Phi negative इसलिए because the work is being done by an attractive force. Simple as that. So इसमें कुछ points accelerate करने पड़ेंगे. So phi is 0 at what distance? At infinity. Because we know that phi is equal to gm over r. आप infinite distance पे चले जाएंगे, so this will become 0 eventually. So phi is 0 at infinity. So this is work done to bring a unit charge or unit mass, and work done by any attractive force. By an attractive force is always negative, right? And you can also say that the mass loses gravitational potential energy when it comes close. तो दो तीन तरीकों से इसको जस्टिफाई कर सकते थे. पार्ट नंबर 2, वन ऑफ द फीचर्स ऑफ फिगर 2.2 जो इसकी बात कर रहा है, ठीक है, is that there is a negative potential throughout. Describe other two features. So what are the other two features that are visually at least justifiable? I can see that the potential of larger mass is more negative than the smaller mass, right? I can see that phi varies inversely, right? We can also observe that they're observing. So this is how it actually goes. So this is for planet number 1, and this is for planet number 2. So they are overlapping over here, so that is why it's actually visible like this. So both are actually inversely related, as we can see from the formula as well. It is related inversely to the distance from the center. Okay. All right. So, and also this maximum potential is closer to the smaller mass or the moon as compared to this planet. Okay. All right. Now he says to draw the gravitational field strength. Now, gravitational field strength, or gravity at least, is a vector quantity. So if they are planets, they're always going to be attracting the masses towards themselves. So if I look at G from this perspective, let's say, okay, and if I look at G from this perspective, let's say, I can see that the value of G will be smaller and its value of G will be higher. Plus, it's a vector quantity. So for the sake of discussion, at least, if I'm considering this to be a positive direction, then this direction will be considered to be a negative direction, because in terms of P, is being pulled in this direction by moon and is being pulled in this direction by the planet. So G has to be in terms of a direction. So let's say if I choose G to be a positive value, right? If I choose G to be, let's say, this much. So, and then I have to look at the maximum potential point, which is this one, approximately. If you look at it closely, this will be the point. So it goes somewhere along this line, where the value of G will exactly be 0. Why? Because both planets are attracting that object by same gravitational attraction. So this is going to go something like this. It goes down, becomes, sorry, let's redraw this again. So it goes down, eventually becomes 0, and then starts rising again to this point. But it will not be as high as this planet, because this is 3 times more massive than that object. Okay. All right. Moving on to question number 3, he says define elastic collision. Simply, we can say that the kinetic energy is conserved. No problem. Or you can say kinetic energy is not being lost. Part 2, state 2, the assumptions of kinetic theory of gases. What are the assumptions? Okay. So this is a repeated question again. We have the volume of atom is negligible as compared to the volume of the container. वो सिर्फ ये कहना चाह रहा है कि कंटेनर के अंदर गैस ने कोई वॉल्यूम ऑक्यूपाई नहीं किया हुआ, वॉल्यूम सिर्फ कंटेनर का ही है. यानी इन सब का वॉल्यूम भी अगर मैं ऐड कर दूं तो वो कंटेनर के मुकाबले में बहुत कम है. यानी इनको बीच में एंटर करने से कंटेनर की जो ऑक्यूपाइड वॉल्यूम है ना, उस पर कोई फर्क नहीं पड़ा। ये सिर्फ इतनी सी बात है कि जो कंटेनर है वो खुद ही है। गैस मॉलिक्यूल्स आर नॉट इंटरफेयरिंग विद द टोटल वॉल्यूम ऑफ द कंटेनर। दैट्स व्हाई he wants to say this. So there are no forces among them. Forces do not exist. This is why the potential energy is zero between gas atoms. It does not exist, right? And this is exactly why, in terms of first law of thermodynamics, when we are dealing with an ideal gas, the internal energy equals to the sum of kinetic energy plus potential energy. This is zero for an ideal gas. So whatever we are doing for an ideal gas, it is primarily in terms of heating. It is primarily in terms of increasing temperature. Okay, so they are in constant random motion. We also know this information as well. And their collisions are instantaneous. Instantaneous collision, right? Okay. और ये बात वो क्यों कर रहा है? He wants to explain that there is a large gap between them. You see, इसको अगर आप बुक में देखेंगे तो लिखा होगा the time spent during collision is much less in comparison to time spent during motion. कि एक गैस मॉलिक्यूल को एक साइड से दूसरी साइड पे जाने में इतना ज़्यादा टाइम लगता है कि अगर वो रास्ते में किसी से कोलाइड कर भी जाएगा ना, तो वो टाइम मैटर नहीं करता एज कम्पेयर टू द टाइम दैट इज यूज टू मूव बिटवीन द कोलिशंस। तो ये सिर्फ इसलिए बात करना चाहता है कि उनके दरमियान डिस्टेंस बहुत ज़्यादा है। सो इट्स अ फैंसी वे, बट इट्स अ मोर डिफिकल्ट वे ऑफ सेइंग द सेम थिंग वन वे और द अदर। बस इतनी सी बात। Again, the part B is actually the exact 100% proof that is solved in the book, that is solved in the class lessons as well, how you're supposed to visualize the equation that we get. Okay, so simply change in momentum is that if the ball is moving towards this side, it comes back. So if this is u, this will be minus u. If you apply the change formula, final momentum minus initial momentum, this one negative sign because of the negative sign of the formula becomes positive. So this whole change becomes 2mu. So this is simply 2mu because your double negative is going to cause a positive. Then he says the shaded phase and the time. So time is calculated by speed equals to distance over time. Replace the situation. So we have t equals to distance over time. Sorry, distance over speed. We have the distance to be 2l divided by the speed is u. Why are we using 2l divided by u? Sorry, 2l because as explained earlier in one of the conditions, the time spent in movement between collisions is much greater. So the time between collisions is non-existent. We can't use that time. So we assume that this block has moved this length twice, and then it is going to collide with the next face again, right? Of course, we are assuming it in one dimension because 1/3 in the final derivation takes care of the 3 dimensions. So 2l by u, average force, basic formula for force from AS is rate of change of momentum. So F equals to delta P divided by delta T. So this comes out as 2mu divided by the change in time was 2L divided by U. Now algebra leads to mu squared divided by L. So mu squared divided by simple L. He asks for pressure. Pressure is simply P equals to F over A. Now we do have the force, which is mu squared divided by L. But where do you find the cross-sectional area? So if you go back, what area is it colliding with? So let's say that this is that area that the gas molecule is colliding with. So this is L, this is also L, so the surface area becomes L square. So this is actually L square. You bring L down in terms of algebra, this becomes mu squared divided by L cube. So mu squared divided by L cube. This exact 100% proof is done in the book as well. If you're confused about this, you can go back to the book to refer to this. He says, okay, fine, what process described in B is extended to 3 dimensions, and of course we add 1/3 to it, containing n number of molecules, each with m traveling at speed c, shown by this equation. Okay, fine. We also have n kt, we also have small n rt. We have these equations equals to PV as well. V is the pressure, V is the volume. Okay, fine. He says, show that this is what it's going to look like. Make this equation look like this one. So we have an equation of PV equals, given in the question, that is 1/3 nmc square. So this is given to us as nm as 1/3 nm rmsc square. We also have an equation written in the syllabus as nkt. So PV is also equal to capital NKT. Students generally forget about this equation and then start the proof again by converting nRT to NKT again. Don't do that. Just memorize this equation. Since both are equal, we can say that 1 over 3 capital NM C square is equal to NKT. So very straightforward, we can see that N is cancelling out from both sides. Take this 3 over there. So what are we left with? We are left with MC square equals to 3 times KT. So the equation looks a bit familiar with this one. Okay. Let's see what the next step would be. So what's missing in terms of kinetic energy? A factor of 1 by 2. So let's divide both sides by a factor of 1 by 2. So this becomes 1 over 2 MC square equals to 3 by 2 KT. Now this is the formula for kinetic energy, half mv square. So this is the kinetic energy, and this is now have been shown to be equal to 3 by 2 KT. So we've shown the proof as well. Then he says the mass of hydrogen molecule is this, and RMS. Now I've explained this before as well, that this is a very nice equation in terms of at least physics. That what does it help us to do? What does this equation help us to do? Now this is the side of one atom, characteristics of one atom. What does this show? Of the whole system. If I know the credentials of just one atom, I can predict the temperature of the whole system. This is why this equation is nice. This is a beautiful equation. So simply use the formula again. Half mass is 3.34 into 10 raised to power minus 27. Velocity square is what we're trying to find out. So C square comes out as this. 3 by 2 Boltzmann constant is 1.38 into 10 raised to power minus 23. The temperature is given to us as 25, which will be converted into Kelvin because this is a thermodynamic temperature. Don't forget to take the under root of C when you finally calculate. Forming correct algebra leads to 1.9 10 raised to power minus positive 3 meters per second. So this is going to be 1.9 into 10 raised to power 3. Question number 4 appears to be from simple harmonic motion. The trolley case, yes. Fixed springs, okay, fine. There should be a frictionless case. Yes, the friction is negligible. Okay, fine. Acceleration graph, a common typical graph of this equation, that A is equal to negative omega square x naught. This is the graph of that equation, and I'm sure that you're familiar with this by now. The common graph. Describe the features of the graph that says that this is simple harmonic motion. So we're just going to describe this equation with reference to this graph. Okay. So first and foremost, it passes from the origin. This is necessary because at x equals to 0, A should be 0. It passes from the origin is the first characteristic. The second thing is that the acceleration is proportional to displacement. As the displacement increases, the acceleration also becomes higher. And acceleration is negative of displacement. If you go towards, let's say, the positive axis, the value of acceleration is negative. And if you go to the negative axis of displacement, the acceleration is positive, which again shows that the restoring force of the acceleration is in the opposite direction as a displacement, right? So we have a negative gradient, you can say. Negative gradient representing that the restoring force F is always acting towards the mean position, which is the displacement, which is the resting position of this trolley, which is, of course, this is the resting position. This is the x naught. Now, what is the restoring force? You see, if you push the trolley towards this side, this spring gets compressed and tries to push it towards this side. This spring gets extended and tries to restore it. So you moved in the positive displacement, but the restoring force of the acceleration is in the negative direction. This is what we mean by a simple harmonic motion's condition, that acceleration and displacement are in the opposite direction. That is why you see the negative sign in this equation. They are both opposite. If the displacement is positive, acceleration is negative. If the displacement is negative, acceleration is positive. They are in opposite direction. One of the conditions of SHM. It says use figure 4.2 to calculate T, the oscillation of the time period. Very easy. This would be A equals to omega square x naught. Pick any coordinate from the graph, right? So I will pick the last extreme coordinate, or be that this one or be that this one, because I know that they are definitely passing from this coordinate. So this is 12 and 0.8. So that will be 0.8 equals to, now omega is from circular motion. We understand this is going to be 2 pi f, but since we want to find time period, that will be 2 pi by t simply. into x naught is 12 centimeters. So let's convert this into meters. This is going to be square. So this comes out, T comes out as finally as 2.43 seconds. Now please be advised, this is a square. When you're done calculating this, don't forget to take the under root after dividing with this 12 centimeters. So this is going to be 2.43. He says on figure 4.2, label letter P, where kinetic energy of the trolley is 0. So we have to label this with P. Now when does it stop moving? On their extreme positions, right? When it goes to this extreme, let's say trolley exists at over here, then starts coming back, then stops here, then starts coming back. So in the extreme positions, we can see that the trolley has to stop to come back again. So at that point, when the speed is 0, when this trolley is not moving, the speed is 0. When the speed is 0, most definitely that is where the point kinetic energy is 0. So those are the extreme points which are labeled already, which are already highlighted. It could have been this point, it could have been this point, but you should label them as P. But we only require 1 point, so letter 1 point. So don't do that into don't mark both of them. I've just explained both so that a student who understands whichever point you're comfortable with, you can accept it. On the line figure 4.2, letter Q on appropriate position, when the kinetic energy of the trolley is equal. Now this is, again, I repeat, this is the point that has been asked repeatedly many times. So we know that the total energy of the oscillation is actually equal to the kinetic energy plus the potential energy of the system, right? Now, what is the kinetic energy? This is due to the half mv square, and potential energy is due to the half kx square, the elastic potential energy. That is what is constantly oscillating between the total energy. Now, if I say that they're both equal, that means that 50% is being shared by kinetic and 50% of the total energy is being shared by the elastic potential. And I've shown you in my lesson a shortcut for this, that 50% kinetic energy or 50% any total energy exists at 70% or 71% of the maximum displacement. Although this part of 1 mark, but let me explain this to you, because this part is going to come for a higher mark, if not this one. What is the maximum displacement of the graph? That is 12. So 12. I can see that 12 multiplied by 0.71, which is 71%. This gives me the answer as 8.5 centimeters, 100% accurate answer. This is where my energies will be 50% divided. So 8.5 is going to come at somewhere this location and over somewhere this location. This will be labeled as Q. If you were looking for something similar to the book that you've understood, then that is this graph. The total energy remains same, right, between the two extreme positions of the displacement, which will be, let's say, minus 12, and this is, let's say, 12. So the kinetic energy goes in the blue graph, right, blue like a blue graph, and the potential energy goes like the black graph. Where do you find this overlapping point? Where do you get this? You see, at this point, both graphs are actually at 50%. So kinetic energy, which is the blue one, is half, and potential energy, which is the black one, is also half. They are exactly sharing that energy 50-50. So you get this, the total energy, as 100%. Where do you get this point? You get this point exactly at the 71% of x naught, which is this one. And to understand this, you can do this proof that kinetic energy standard or current kinetic energy is equal to half m omega square x naught square minus x square divided by 2 times the kinetic energy divided by half m omega square into x naught square. But how do we get this 1/2? You see, we are looking for 50% kinetic energy, right? हम तो उसके लिए ढूंढ रहे हैं. तो ये half kinetic energy कब होगी as compared to the full 100% kinetic energy? तो हमें पता है फुल किनेटिक एनर्जी तो सिर्फ सेंटर पोजीशन पे हो सकती है जब x एग्जिस्ट ना करे और टोटल x नॉट ही हो. लेकिन जब आप ये 1/2 को अलजेब्रा करोगे तो ये 2 नीचे आ जाता है, ठीक है. तो दैट इज व्हाई आई हैव रिटन डाउन दिस 2 ओवर हियर. सो व्हाट डज दिस कम डाउन टू? हमें किनेटिक एनर्जी का तो नहीं पता, तो के से कैंसिल हो जाएगा, हाफ एम ओमेगा स्क्वायर से कैंसिल हो जाएगा. वी आर लेफ्ट विद दिस इक्वेशन व्हिच इज 1/2 इक्वल्स टू x नॉट स्क्वायर माइनस x स्क्वायर डिवाइडेड बाय x नॉट स्क्वायर. क्रॉस मल्टीप्लाई करें, अलजेब्रा करें प्रॉपर्ली, तो ये है वो डिस्प्लेसमेंट जो हम निकालना चाहते हैं. दिस कम्स आउट एज x स्क्वायर इज इक्वल टू x नॉट स्क्वायर डिवाइडेड बाय 2. अंडर रूट लेके जाओगे तो ये क्या बनेगा? x नॉट डिवाइड बाय अंडर रूट 2. अंडर रूट 2 को कैलकुलेट करोगे 1/√2 को, तो ये बनता है 0.71 ऑफ x नॉट, विच इज व्हाट आई हैव बीन सेइंग कि ये 71% है। तो ऑफ द मैक्सिमम डिस्प्लेसमेंट पे आपको 50% किनेटिक एनर्जी मिलेगी और उसी पॉइंट पे आपको बाकी एनर्जी ग्रेविटेशनल पोटेंशियल में मिलेगी। यहाँ तक समझ आई बात? ठीक है, ऑलराइट। सो ये पॉइंट यहाँ पर होना चाहिए था। ऑफ कोर्स आई अंडरस्टैंड दिस इज फॉर 1 मार्क, नो नीड टू गो थ्रू ऑल ऑफ दिस, बट आई एम एक्सप्लेनिंग दिस अगेन एंड अगेन बिकॉज आई हैव सीन दिस क्वेश्चन कम इन द पेपर एंड यू हैव टू मार्क दिस पॉइंट एक्यूरेटली। ओके, डिफाइन इलेक्ट्रिक पोटेंशियल, अगेन ये सवाल बहुत दफ़ा आ चुका है। इट इज़ अ वर्क डन टू मूव a unit positive charge from infinity to that point. We have already done this question many times, you can memorize this. वो कहते हैं जी कि सफ़ियर है हमारे पास, सफ़ियर के पास वोल्टेज है, इलेक्ट्रिक पोटेंशियल है विच इज़ V। तो बताएं जी कि ये कैसे बनेगा? हाउ आर यू गोइंग टू मेक दिस इक्वेशन? हाउ आर यू गोइंग टू प्रूव दिस? सो सिंपली पुट वी हैव एन इक्वेशन दैट इज Q equals to CV and we have an equation V equals to Q divided by 4 pi epsilon naught R. Now let's rearrange this equation to look like Q divided by C equals to V, and this is already that, so let's equate both of them. So when we equate both of them we get Q by C is equal to Q divided by 4 pi epsilon naught R. We can see very clearly that a Q cancels out, and after cross multiplication we can see that C comes out equals to 4 pi epsilon naught R. So the capacitance of a sphere, for example, अभी तो हमने पैरेलल प्लेट्स पढ़े हुए ना, पैरेलल प्लेट कैपेसिटर तो पढ़े हुए। The capacitance of a sphere depends on its radius. It can only be increased or decreased physically by changing its radius. Okay, fine, good. So let's come down to this part. This is a bit difficult. This is going to take a long time, but I will try to explain this to you in terms of a longer calculation, but easier to understand. Or you can use the examiner's method that is given in the paper. I will also explain that as well, but let's see what method I'm going to use. So what is the situation? He says that we are going to charge the 13 centimeter sphere up to 4.5 kilowatts. So I can use Q equals to CV to calculate how much charge was stored on the spheres. Then he says that another sphere is brought closer to it. So they're just acting like a capacitor. First you charge this one capacitor, and now you're going to charge another capacitor, and he says that the voltage until that they achieve the same potential. And this is what happens. Voltage जब तक बराबर नहीं हो जाती दोनों की, करंट गुजरता रहेगा। तो ये कॉमन पॉइंट मुझे पता चल गया, द कॉमन पॉइंट बिटवीन देम इज एक्चुअली द वोल्टेज। इससे जो वो रिलेशनशिप निकालता है ना, वो ये वाला निकाल लेता है कि हमें पता है दैट Q is equal to CV, and since voltage is proportional, Q will be proportional to C. ठीक है, so if we wanted to compare two situations, so then and C is proportional to R, और कैपेसिटेंस तो हमें गिवन ही नहीं है, तो हम Q का कंपैरिजन करेंगे R के साथ। तो इक्वेशन क्या बनाता है? Q1 is equal to R1 divided by Q2 divided by R2। ठीक है, तो इसमें उसने क्या कर दिया है, उसने क्या किया जी, कितना चार्ज लूज किया शुरू से लेकर अब तक, कितना चार्ज लूज किया, ठीक है, डिवाइडेड बाय दिस Q, ठीक है, एंड इक्वल्स टू R1 जो कि इसकी रेडियस है जो कि 13 है, डिवाइडेड बाय 5.2। तो यहाँ से वो Q का टर्म्स निकाल लेते हैं, यहाँ से वो Q निकाल लेता है कि कैसा कितना बनेगा, ठीक है, और Q उसने जो इनिशियल वाला है वो कैलकुलेट ऐसे ही किया होता है। बट ये तो एग्जामिनर का मेथड हो गया। लेट्स एक्सप्लोर दिस इन टर्म्स ऑफ कैपेसिटर्स। अगर ये कैपेसिटर के तौर पे ट्रीट होते तो क्या होता? सो पहले हम दोनों की कैपेसिटेंस निकालते हैं। सो कैपेसिटेंस ऑफ ईच स्फीयर व्हिच वुड हैव बीन 4 पाई एप्सिलॉन नॉट R। तो लेट्स रिप्लेस वैल्यू, सो दिस वुड हैव बीन सिंपली 4 पाई 8.85 into 10 raised to the power minus 12। पहले हम 13 सेंटीमीटर पुट कर लेते, सो 13 divided by 100, this came out as 14.5 picofarads। The other one was 4 pi into 8.85 into 10 raised to the power minus 12, उसका रेडियस 5.2 था, so 5.2 divided by 100 gives me 5.8 picofarads। चार्ज आपने किसको किया था? 14 वाले को। और जब आप एक स्फीयर को चार्ज करके दूसरे के पास लेकर आ रहे हैं तो ऐसा लगता है जैसे आपके पास एक कैपेसिटर था जिसको आपने चार्ज किया और अब आपने उसको किसी दूसरे कैपेसिटर के साथ लगाया, एंड दे विल बी कंसिडर्ड इन पैरेलल। पैरेलल में क्यों कंसिडर कर रहे हैं? क्योंकि पैरेलल में वोल्टेज क्या रहती है? सेम, और उसने भी हमें यही कहा दैट दे शुड गेट सेम पोटेंशियल, सो दैट इज व्हाई वी आर अज्यूमिंग दैट दे विल बी कनेक्टेड इन पैरेलल। सो फर्स्ट लेट्स फाइंड आउट हाउ मच चार्ज हैज बीन स्टोर्ड इन द सिस्टम। सो Q equals to CV, you stored it on this capacitor, so this will be 14.5 into 10 raised to the power minus 12 at what voltage? 4.5 kilovolts, which was 4.3 into 10 raised to the power 3 kilo. So the total charge held in the first sphere comes out as 6.5 into 10 raised to power minus 8 coulombs. This is the charge that is going to get transferred, or some charge will be transferred on a smaller sphere until the voltage becomes same. Now, we can connect them in this way, that this was, let's say, 14.5 picofarad. Sorry. Yes, 14.5. Let me erase this. This was 14.5. And this was 5.8 picofarad. And now we understand that they are connected in parallel. Right? So if they are connected in parallel, what will be the total capacitance? They will simply be added. So 14.5 plus 5.8 gives me an answer of 20.3 picofarads. तो इन दोनों को मिला देते तो हमारे पास टोटल कैपेसिटेंस ये बनती, ठीक है. तो अब जब टोटल कैपेसिटेंस आ गई हमारे पास और हमें पता है कि टोटल चार्ज भी कितना है, तो अब हम वोल्टेज निकाल लेते हैं कि अगर इतने कैपेसिटर पे मैंने इतना चार्ज स्टोर कराना होता तो मुझे कितनी वोल्टेज चाहिए थी, ठीक है, बिकॉज दैट इज व्हाट दे आर गोइंग टू कम डाउन टू, राइट. So to store that amount of charge on this capacitor, how much voltage was actually required? So that would have been Q equal to CD. How much charge are we storing? We're storing 6.5 into 10 to the power minus 8. What is the combined capacitance? That is 20.3 pico multiplied by voltage. So the voltage comes out as 3201 volts. अगर आप इस मेथड से करोगे तो आपका 3210 आ जाता है, जो कि ज़्यादा डिफरेंस नहीं है, ठीक है. थ्योरी करेक्ट है ना हमारी, सही है. तो अब हमें पता चल गया कॉमन वोल्टेज कितनी है. व्हाट इज द कॉमन वोल्टेज, राइट. सो नाउ वी कैन फिगर आउट व्हाट वोल्टेज और व्हाट चार्ज हैज बीन गेन्ड बाय दिस कैपेसिटर बाय सिंपली यूजिंग Q इक्वल्स टू CB अगेन. हमें नहीं पता कितना चार्ज है, बट हमें उसकी कैपेसिटेंस का पता है. कैपेसिटेंस इज 5.8. सो 5.8 टू 10 to the power minus 12. आज की वोल्टेज कितनी है? 3201, जो कि कॉमन वोल्टेज दोनों के लिए. तो हमारे पास Q आ जाता. Let's calculate this. So this is going to be 5.8 E minus 12 into 3201, which comes out as 1.85 into 10 raised to the power minus 19 coulombs. So it has 1.9 into 10 raised to the power minus 19 coulombs. एक और तरीके से भी इसको सोच के देख लेते हैं. Let's explore all the possibilities. What if you had found the charge on this capacitor? 14.5 पे अगर आप ये लगा देते 14.5 पिको यानी पावर माइनस 12, वोल्टेज 3201, जब ये लगाते ना तो आपके पास आंसर आता 4.64 पावर माइनस 8. इसका क्या मतलब हुआ? इट हैड 6.8 शुरू में आज, और आज इसके पास 4.64 है लूज करने के बाद. तो कितना चार्ज ट्रांसफर कर दिया? फिर आप 6.5 को 4.64 में से माइनस करते तो भी यही आंसर आना था, ठीक है. The number of electrons in it, they have been transferred from one charge, one sphere to the other. ठीक है. If this looks cumbersome, if this looks long method, because conceptually ये ठीक है, so you can also employ this idea that is explained in the examination question as well, in the marking scheme as well. So personally मुझे ये पसंद है क्योंकि इसमें मैथमेटिक्स है, वैल्यूज हैं, विजुलाइज करना आसान है, सोचना आसान है. बस इसमें एक परेशानी होती है, एक सिचुएशन समझ नहीं आती, वो ये है कि जब इन दोनों को आपने कनेक्ट किया है तो इनको आप पैरेलल अज्यूम करोगे. पैरेलल क्यों अज्यूम कर रहे हैं? क्योंकि इन्होंने सेटल डाउन एक कॉमन वोल्टेज पे करना है, ठीक है, ओके. और दूसरा, पैरेलल की हमें बात पता है कि चार्ज शेयर हो जाता है. जो चार्ज इसके पास है वो थोड़ा सा इसके पास होगा, थोड़ा सा इसके पास होगा, टोटल चार्ज सेम रहेगा. सीरीज के अंदर चार्ज ट्रांसफर हो जाता है, कंप्लीटली शेयर नहीं होता, और वोल्टेज भी शेयर होती है. यहाँ तो वोल्टेज सेम है अल्टीमेटली. ओके, सो यहाँ पे वो आपको कहता है क्वेश्चन नंबर 8, ही सेज दैट ड्रॉ on figure 8.1, draw an arrow magnetic field. So you're going to use the right hand grip rule, of course. The current is into the page, right? So you will point the thumb into the screen, and when you turn your fingers, they're going to curl like this. So that means that the direction of magnetic field around P is actually like this, according to right hand grip rule. And when this magnetic field reaches Q, most definitely it is going to go like this, concentric circles, and at this point it will be in downward direction, right? If you were to make these circles completely like this, तो वो ऐसे ही बननी वहां तक पहुंचते, ठीक है. उसके बाद he asks in the second part and label this B. So this is B. Then he says what's going to be the force on them, and we memorized this in O levels as well, that if current is in the same direction they will attract each other, so the force will be in this direction, represented by F. Then he says stated the reason how the magnetic magnitude of the force acting on P compares with the magnitude acting on wire Q. इन दोनों में करंट डिफरेंट होता, सेम होता, इससे कोई फर्क नहीं पड़ता. इसी वो कहता है P में जो करंट है वो I है और इसमें 2I है. देखें कोई फर्क नहीं पड़ेगा. क्यों? If we are figuring out the force on a current conducting wire, that will be F equals to ILB. ठीक है, कोई बात नहीं. If you're considering the current in wire P, तो मैं उसको लिख लेता हूँ. So this is going to be IP multiplied by LP, length of P, multiplied by जिस magnetic field में वो expose हुआ है. ये जो magnetic field में expose हुआ है किसकी वजह से? ये तो Q की वजह से. Q की भी magnetic field है क्योंकि उसमें से भी current पास कर रहा है. ऐसे ही है ना? ठीक है. और हमें पता है from simple ideas that अगर हम if in through any conductor you increase the current, the magnetic flux density increases, it becomes a stronger electromagnet, it becomes a stronger magnet. So I can say that this magnetic field that this first conductor is experiencing is because of my conductor Q. So when we use this equation as IPLP, but this is actually a proportionality or dependence on its own current, which is IQ. So मैं B की जगह IQ लिख रहा हूँ क्योंकि वही इसका करंट बनाने वाला है. तो आप देखो तो IP और IQ मल्टीप्लाई हो रहे हैं. अगर आप इसके परस्पेक्टिव से देखते हैं तो फिर क्या बनता? F equals to IQ LQ multiplied by BP, जो कि मैग्नेटिक फील्ड P की वजह से बनेगी क्योंकि उसकी मैग्नेटिक फील्ड है तो ही ये इंटरेक्ट कर रहा है उसके साथ. तो यहाँ पर फिर क्या हो जाएगा? IP. अब आप देखो IQ multiplied by IP, चाहे इसके परस्पेक्टिव से देख लो चाहे इसके परस्पेक्टिव से देख लो, वट एवर परस्पेक्टिव यू लुक एट इट फ्रॉम, you are always getting a product of IP and IQ in any direction, in any way possible. That is why the force on both of them is exactly the same. So हम क्या लिखेंगे? What we will write down, force is proportional to the product of current of IP and IQ. That's why force is same according to Newton's third law. Whatever force P is exerting on Q, Q is also exerting on P, right? So the forces are going to be same magnitude, but they are going to be in opposite directions. Next question, he says direction of force P compares, so we're just going to write down opposite. I have given that information over here as well. Question number 9, state what is meant by photoelectric effect. So what is the photoelectric effect? Again, this is a repeated definition, please memorize this. This is the emission of electrons, right? So this is the emission of electron from where? From a metal surface. Kab? When this is going to happen? When an electromagnetic radiation of certain frequency is radiated or exposed to the metal, and we know this as work function being equal to HF. You already know this. What is work function? Again, वो सवाल आ ही गया. So minimum energy needed for electrons to escape. कहाँ से? Escape the metal surface. The definitions are taken from the book. I'm not adding anything, I'm just explaining them. So it's illuminating white light, illuminated with light, calcium is there, produced a wavelength less than. So he says that the photoelectric current produced when the frequency is less than no photoelectric. So the threshold frequency is given to us, F naught. We need at least this much energetic photon to hit the metal surface so that it can produce an electron, or it can eject an electron. State the name. So we know that the name of that frequency is threshold frequency. We cannot go below this. Explain how the photon model electronic radiation accounts for this phenomenon. So what he wants you to say is the discrete energy level. एक तरीके से या दूसरे तरीके से आपको बस ये कहना चाहता है कि ये discrete energy levels होते हैं, discrete packet of energy होते हैं. एक लेवल को चेंज करेंगे तो फोटोन निकलेगा. वो बस ये चीज आपसे पूछना चाहता है. क्वेश्चन बार बार चेंज करता जाएगा, आंसर इसका हमेशा सेम ही होता है. सो इसको भी अपनी वोकैबुलरी का हिस्सा बना लें कि अगर ऐसा सवाल कभी आ जाए तो हमने उसका सिमिलर जवाब देना. सो क्या जवाब है जी? फोटॉन्स हैव स्पेसिफिक एनर्जी. फोटॉन स्पेसिफिक एनर्जी. or you can say they have discrete energy. And where does this discrete energy come from? Because the energy levels are discrete. They are confirmed, they are definite, right? So the photon energy is actually proportional to the frequency, of course. Planck's तो constant है ना, तो उसके ऊपर depend करती है, ठीक है? So one photon only releases one electron. Again, photoelectric emission की condition है. क्योंकि उसने कहा है कि जी photon model जो हमने पढ़ा हुआ है वो इसके ऊपर कैसे फिट होता है, तो वो हमें इसमें नजर आ जाता है. ये कौन सा वाला पॉइंट था, ये मैंने एक्सप्लेन किया हुआ है, ये इंटेंसिटी वाला पॉइंट है. नंबर ऑफ photons equal to number of electrons if you cross the threshold frequency. So emission only if the photon energy is greater than the work function, or at least equal to the work function. ये बात भी हम पहले कर चुके हैं. तो कहते हैं calculate the work function of calcium. So we know that the work function is equal to hf, or the photon energy. So we have a 6.6v Planck's constant. We have the frequency when this starts to happen, 6.93 power 14 into 10 raised to power 14 hertz. So the energy comes out as, now we require this in electron volts. So this is why I was thinking, why is it for 2 marks? Because then we have to, this answer will be in joules. ये joules में आएगा. You'll have to convert this into electron volts. You'll have to divide this with this number. Because we know that this is, these are the number of joules per electron volt. So joule से cancel होता है, electron volt ऊपर चला जाता है. So our answer will come out as 2.87 electron volts. 2.87. Question number 10 is from transformers. Number of turns are given, output resistance is given. State the function of the iron core. So why is it there? It increases the strength of magnetic field. It increases the strength of magnetic field or magnetic flux, which is B. क्योंकि soft iron core easy to magnetize, demagnetize, वो लोग वाली बात है. Explain why iron core is laminated. हमने इसको laminate क्यों किया होता है? Because if you look at it from the 3D dimensional perspective, this is what the transformer is going to look like. He says, why is this laminated and driven into slices? Why are we doing this? So that eddy currents cannot exist. I've also explained this in the video uploaded in the lesson as well. Why have we done this? To reduce energy loss by eddy currents. And eddy currents are there. Why are they there? You see, when you pass the changing current through this, the domains are changing in this iron core. The iron core is a conductor itself. So according to Faraday's law of electromagnetic induction, whenever a conductor experiences a changing magnetic field, which is passing through this, it will experience an induced EMF. So एक इसके ऊपर induced EMF आ जाता है. Induced EMF आ गया. Now when there is an induced EMF, and this is a conductor as well, the current will start flowing. When this current starts flowing, तो हमें पता चलता है कि जो flowing current है उसके अराउंड तो magnetic field होती है, circular, ठीक है. That magnetic field starts interacting with this magnetic field, which we introduced from the outside by providing an alternating current. तो हम तो चाहते थे ये interfere ना करे, तो ये interfere करना शुरू कर देता है. So this is actually a physical manifestation of Lenz's law. कि जिसने बनाया था, इस करंट ने इसको बनाया है. ये करंट ना देते तो डोमेन्स ना आती, डोमेन्स चेंज ना होती तो इसमें इंड्यूस्ड ईएमएफ ना आता, ईएमएफ ना आता तो करंट ना आता. अब जब करंट आ गया है तो इसने इसी की मैग्नेटिक फील्ड को अपोज करना शुरू कर दिया. सो दिस इज द कॉज ऑफ लॉस इन अ ट्रांसफॉर्मर, जिसको हम एडी करंट लॉस कहते हैं. तो दिस इज व्हाट ही वांट्स यू टू अंडरस्टैंड. दिस इज व्हाट ही वाज आस्किंग. लैमिनेट क्यों कर देते हैं? लैमिनेट करने से क्या होता है? जब आप इसके दरमियान लैमिनेशंस डाल देते हो, स्लाइसेस बना देते हो, तो इसकी रेजिस्टेंस बढ़ जाती है. रेजिस्टेंस बढ़े, आप ईएमएफ को तो नहीं रोक सकते. यू कांट स्टॉप इंड्यूस्ड ईएमएफ फ्रॉम अकरिंग और फ्रॉम अपीयरिंग ऑन द आयरन कोर. व्हाट यू डू is according to Ohm's law, I want to reduce the current, so I will increase the resistance. How can I increase the resistance? By cutting the core into slices and putting a plastic sheet between them. ये करने से क्या होगा? Resistance is proportional to length over A. मैं क्रॉस सेक्शनल एरिया कम कर दूंगा तो रेजिस्टेंस बढ़ जाएगी. तो क्रॉस सेक्शनल एरिया यहाँ पे स्लाइसेस का कम होता जा रहा है. पहले पूरा ब्लॉक था करंट को इंड्यूस होने के लिए, अब उसके पास सिर्फ स्लाइसेस हैं. तो क्रॉस सेक्शनल एरिया कम हुआ, रेजिस्टेंस बढ़ गई. तो सेम इंड्यूस्ड ईएमएफ के लिए जो आपके पास वोल्टेज है वो उतना करंट नहीं पास करवा पाएगी. ये तो चेंज नहीं हो सकता. हमने रेजिस्टेंस बढ़ा दी जानबूझ के ताकि करंट, एडी करंट कैन बी रिड्यूस. इफ द एडी करंट आर रिड्यूस्ड then they will not disturb the magnetic field that we are trying to introduce in the core. Okay, all right. So this is what this part, or the answer of this part means. So to reduce the energy loss by eddy currents, और वो marking scheme में उसने क्या लिखा हुआ है? Induced currents. भाई वो induced currents कहाँ पे हैं? Core में. उनका नाम क्या है? Eddy currents. ये पता होना चाहिए आपको. Okay, so the input voltage sinusoidal alternating peak of 12 kilovolts period 40 millisecond कहते हैं maximum peak. अब क्योंकि सिर्फ हमें maximum ही चाहिए, तो हम मैक्सिमम को यूज करके इक्वेशन यूज करेंगे, विच वाज नंबर ऑफ टर्न्स ऑफ सेकेंडरी डिवाइडेड बाय नंबर ऑफ टर्न्स ऑफ प्राइमरी इक्वल्स टू वोल्टेज ऑफ सेकेंडरी डिवाइडेड बाय वोल्टेज ऑफ प्राइमरी. सो नंबर ऑफ टर्न्स वर गिवन एज 625, दिस वाज 25,000. वोल्टेज ऑफ सेकेंडरी इज नॉट नोन एंड द पीक वोल्टेज इज 12 किलो, दैट इज नोन. सो ये उधर चला जाएगा. सो x इज इक्वल टू सेकेंडरी वोल्टेज विच इज गोइंग टू कम आउट एज एग्जैक्टली 300, और यू कैन से 0.3 आता है क्योंकि 12 किलो यूज करें ना, सो दैट विल बी 300 volts. So this is going to be 300, or you can open this up to completely as 12,000, तो फिर 300 direct आ जाता है. Calculate RMS, very straightforward. RMS current V by this is current. हमने voltage निकाली है. So to calculate V equals to IR, I need VRMS. So VRMS would be 300 divided by under root 2. Current I don't know, but the resistance is given in the question as 640. So let's put that 640 over here. So when you find the current, this is going to come out as current जो है वो आपके पास आ जाता है 0.331. So this is going to be 0.33 amperes. This graph has been asked many times, तो इसको भी बना लेते हैं. तो इसके लिए कुछ पॉइंट्स होंगे. ये 3 marks का ग्राफ है, तो इसको आपने ऐसे ही नहीं बना देना. You have to draw it properly. So first we need to figure out what is going to be the peak power. Right, because हमें extreme power बतानी है. So what will be the peak power? Now we have a relationship that peak power, if divided with 2, is actually equal to the RMS power. और आप कह सकते हैं कि RMS is actually 2 times the peak power. इसको ऐसे भी देखा जा सकता है. So अब हमारे लिए RMS निकालना आसान है. ठीक है, हम RMS पावर निकाल लेते हैं. कैसे? By multiplying IRMS with VRMS. So current कितना था RMS, हम पिछले पार्ट में निकाल चुके हैं, that is 0.33. VRMS कितना है? We have the peak voltage as 300. So if we divide this with under root 2, we can find this out. So this is 300 divided by under root 2. This comes out as 69.9 watts, which will be exactly 70 watts. So the average power through this resistor is actually 70 watts. So peak power कितनी होगी? उसका double. ठीक है. So my RMS came out as 70 watts. My peak power will come out as 140 watts. ये हमें 100% पता है. कैसे? अगर मेरे पास वोल्टेज का ग्राफ होता है, लेट्स से ये मेरे पास कहाँ पे बना है ग्राफ, नहीं बना हुआ. मैं वी आउट की बात करता हूँ. ये मेरे पास वी आउट है जो कि 300 पे है, और ये मेरे पास आई आउट है. अब करंट जो है उसका तो हमने RMS बनाया, मैं वो करके दिखाता हूँ. ये तो RMS है क्योंकि हमने VRMS को यूज करके निकाला था. क्या इसका मैं पीक निकाल सकता हूँ? यस, मैं इसको 3.3 को अंडर 2 से मल्टीप्लाई कर दूँ तो मुझे पीक करंट मिल जाएगा. तो कर लेते हैं. 0.33 मल्टीप्लाई बाय अंडर 2, तो मेरे पास आ गया 0.47. 0.47 एम्पेयर. तो इसका क्या मतलब है कि अगर मेरे पास करंट वाला ग्राफ भी होता तो उसकी सबसे पीक वैल्यू होती 0.47. मैं पीक पावर की बात कर रहा हूँ. ठीक है, इफ आई एम डिस्कसिंग अबाउट पीक पावर, दैट वुड बी इंस्टेंटेनियसली हैपनिंग एट दिस इंस्टेंट. किसी एक लम्हे पे ये काम होगा. तो मल्टीप्लाई कर लेते. लेट्स मल्टीप्लाई 300 विद 0.47. 0.47 सही है. तो पी पीक जो कि सिर्फ एक दफ़ा ही आना है उसकी ज़िंदगी में, या इधर आएगा या उधर आएगा, इज एक्चुअली 300 मल्टीप्लाइड बाय दिस 0.47. करके देखते हैं. सो 300 मल्टीप्लाई बाय, लीजिए इसको कैलकुलेट करेंगे तो आपका आंसर 300 मल्टीप्लाई बाय 0.47 141 आ जाता है. लेकिन अगर आप पूरी वैल्यू लेंगे ना, जिस तरह आपके पास ये इसकी कंप्लीट वैल्यू ले लेते हो, 300 बाय अंडर 2 की पूरी वैल्यू ले लेते हो, पूरी करंट की वैल्यू लेके अंडर 2 से मल्टीप्लाई करके फिर आंसर निकालते हो, तो एग्जैक्ट डिट्टो 140 आता है. तो हम जो प्रूव कर रहे थे और जो हमारे पास जो रिलेशनशिप हमें याद है, दैट इज 100% ट्रू. और ये 1/2 क्यों बनता है, ये हाफ क्यों बनता है? इट गोज समथिंग लाइक दिस, दैट इफ यू आर कैलकुलेटिंग लेट्स से पी RMS, तो आपको क्या क्या चाहिए होता है? IRMS और वी आर एम एस। तो अगर हम इसमें ये रिप्लेस करते हैं आई नॉट जो कि पीक वैल्यू है डिवाइडेड बाई 2 मल्टीप्लाई बाई वी नॉट जो कि पीक वैल्यू है डिवाइडेड बाई 2, तो ये क्या बन गया, आई नॉट वी नॉट डिवाइडेड बाई 2, अंडर टू मल्टीप्लाई करें 2 बनता है, और ये क्या है, उनकी पीक वैल्यूज है। आई नॉट और वी नॉट क्या है, पीक वैल्यूज है। सो दिस इज गोइंग टू बी पीक डिवाइडेड बाई 2 इक्वल्स टू पी आर एम एस। तो अगर मुझे एवरेज पावर का पता है, मैं बता सकता हूँ किसी एक मोमेंट पे इस अप्लायंस ने पीक मैक्सिमम कितनी पावर निकाली होगी या कितनी पावर डिमांड की होगी, 140 वाट्स। ओके, ऑलराइट, बट इट इज सो शॉर्ट लिव्ड कि हमें फिर एवरेज पावर के साथ काम करना पड़ता है क्योंकि ये होता है एक दफ़ा ही है। सो नाउ आई हैव एन एवरेज पावर, आई हैव द पीक पावर एंड द फुल टाइम पीरियड इज एक्चुअली 40। तो इसका मतलब है मेरे पास जो करंट और वोल्टेज की जो वेव बननी है वो कुछ इस तरह से बननी है, जिसका मतलब क्या हुआ कि मेरे पास जो पीक्स आनी है वो कहाँ पर आएंगी, मेरे पास जो पीक आएगी दैट इज गोइंग टू एग्जिस्ट, एक तो 10 पे एग्जिस्ट करेगी और दूसरा 30 पे एग्जिस्ट करेगी, और क्योंकि यहाँ पे करंट जीरो है, वोल्टेज जीरो है, तो ये मेरे पास सॉलिड पॉइंट्स बनते हैं। ठीक है ना, इसने मुझे कहा होता है क्वेश्चन के अंदर दैट द पीरियड ऑफ दिस ग्राफ इज एक्चुअली 40 मिलीसेकंड, इट वाज ऑलरेडी डिस्कस्ड। सो सिंस द पावर इज ऑलवेज पॉजिटिव भी क्यों, ये भी देख लो, जब इस रीजन में हो तो वोल्टेज भी पॉजिटिव है, करंट भी पॉजिटिव है, जब नेक्स्ट रीजन में आते हो तो वोल्टेज भी नेगेटिव है, करंट भी नेगेटिव है, तो जब दोनों को मल्टीप्लाई करोगे, नेगेटिव वोल्टेज मल्टीप्लाई बाय नेगेटिव करंट, तो आंसर क्या आएगा, पॉजिटिव। तो ये ग्राफ हमेशा रहना ही पॉजिटिव साइड पे, ठीक है। सो दिस इज गोइंग टू लुक समथिंग लाइक दिस। अच्छा, इसमें एक और प्रॉब्लम है, आप लोग हो सकता है 140 तकरीबन यहाँ पर आता है, तो आप लोगों ने ये 2 पॉइंट्स बना लिए, आप लोग हो सकता है कि इसको इस तरह से ड्रॉ कर दो, ये गलत होगा। ये गलत क्यों होगा वो भी मैं आपको बताता हूँ। दिस इज रॉन्ग बिकॉज जब आप इंस्टेंटेनियस पावर की बात करते हो ना, जब आप यहाँ पर जाते हो, लेट्स से व्हेन यू आर डिस्कसिंग अबाउट दिस वन, ये मैंने पहले भी वीडियो में एक्सप्लेन किया होगा, तो आपका जो वोल्टेज का फंक्शन है दैट गोज वी कॉस साइन ऑफ ओमेगा टी, मल्टीप्लाई किससे करें आप, आई नॉट साइन ऑफ ओमेगा टी से, तो ये आप पावर निकाल रहे हो मल्टीप्लाई वोल्टेज विद करंट, इंस्टेंटेनियस ऑफ कोर्स, और ये टी आप अपनी मर्जी का पुट करते हैं कि मुझे इस टाइम पे बता दो, इस टाइम पे बता दो, इस टाइम पे बता दो, दैट इज ऑफ योर चॉइस। व्हेन यू सिंप्लीफाई दिस बिकम्स आई नॉट वी नॉट साइन स्क्वायर ऑफ ओमेगा टी। सो पावर इज एक्चुअली, अगर हम साइन फंक्शन को देखें तो स्क्वायर हो रहा है, तो साइन स्क्वायर जो बेटा उसका ग्राफ, साइन का अगर ऐसे ग्राफ बनता है ना, तो साइन स्क्वायर का ग्राफ इस तरह से बनता है, बट इसमें एक प्रॉब्लम है, इसमें छोटी सी वेरिएशन है, दिस इज गोइंग टू गो लाइक दिस, इसमें स्मूथ चेंजेस आते हैं, इसमें एब्रप्ट चेंजेस नहीं होते, ये ऐसे नहीं होता, ये डायोड रेक्टिफिकेशन वाला ग्राफ नहीं बनेगा, ठीक है। तो प्लीज थोड़ा सा इसमें केयरफुल होना है आपने, ये पहले भी चीज मैंने एक्सप्लेन पेपर में की है। सो दिस इज गोइंग टू गो लाइक अ स्मूथ ट्रांजिशन फ्रॉम 0 अप टू द मैक्सिमम 140, उसके बाद दोबारा नीचे आएगा, फिर 0 के साथ स्मूथली गुजरेगा, फिर 140 तक जाएगा, and then it's going to come back to 20. Please note that this is going to be a smooth transition primarily because of that sine square theta function. If it had been a diode rectification or simple voltage or simple current, then it would have gone like this. Yes, but this is not. This is actually the graph of power, which is going to be like a smooth transition. This is why the graph is for 3 marks. Be careful. Okay, so then he asks you, with reference to figure 10.2 with mean power, why the mean power is 70 watts. He says why the mean power is going to be 70 watts. Okay, so 70 watts पे अगर हम देखें, so what will be the 70 watts? This is 70 watts. So 70 watts पे अगर आप एरिया अंडर द ग्राफ निकालो ना, जो ये एरिया बन रहा है वही एरिया इधर ऊपर बनेगा जब टोटल थ्रू आउट दिस कंप्लीट पे करोगे। तो सिंस इट इज सिमेट्रिक अबाउट द मीन पोजीशन और द 70 वॉट पावर, अगेन ये मैथमेटिक्स वाली बात है, फिजिक्स का इसमें कोई मसला नहीं था, दिस इज प्योर मैथमेटिक्स, ठीक है। ये कॉस स्क्वायर का या साइन स्क्वायर का फंक्शन होता ही ऐसा, ये सिमेट्रिक होता है अबाउट द मीन पोजीशन, अबाउट द एवरेज वैल्यू, ठीक है, यानी इसके अलोंग सेंटर पॉइंट के पीक के सेंटर में सिमेट्रिक होगा, जितना एरिया ऊपर है उतना ही नीचे होगा। सो हम इसको सिंपल इंग्लिश में कैसे लिखेंगे, दैट द पावर कर्व इज सिमेट्रिक अबाउट व्हाट, अबाउट द वाई एक्सिस एंड अबाउट द मिड पॉइंट, जो कि 70 वॉट्स वाली बात आपको मैंने बताई है, ये डायग्राम वाली बात है, ठीक है, एरिया से निकलता है। and hence mean power is half the peak power, right? So that's why the average power is half the peak power. Okay. Question number 11, he says piezoelectric crystal. तो मेरी knowledge के according ये सवाल जो है ये अल्ट्रासाउंड में से होगा. Whether crystal बता दें diagnostic information about internal structure, describe the function of quartz crystal. तो हम क्यों यूज करते हैं? We use the quartz crystal to generate ultrasound. So first we generate ultrasound कैसे? By providing a high frequency AC signal. हम जानबूझ के उसको alternate signal देते हैं ताकि crystal अपनी shape को change करे. When the crystal changes shape, it introduces compressions and rarefaction and produces ultrasound. Then we use the crystal to detect the ultrasound when they are reflected back. Same crystal से detection भी करवा देते हैं. Because when they are going to come back, the crystal will experience those shock waves of sound and experience a change of shape. When it experiences a change of shape, there is going to be a voltage induced at the alternate faces of that crystal. So those voltage can be read again, right? Reflected back, generate an AC signal, which is then processed by the computer, to create an image. Simple. Okay? Acoustic impedance is Z equals to rho multiplied by C. Rho is the density. So we simply define this formula over here. It is a product of the speed of sound in the medium and the density of that medium, or product of speed of sound in that medium with that medium's density. So simple English में लिख देना था आपने. Describe qualitatively, यानी theory के हिसाब से मुझे बताएं, how specific acoustic impedance of two materials affects the intensity reflection coefficient at the boundary between the two mediums. You see, ये boundary है, ठीक है, ये मेरे पास medium 1 है. Let's say this is medium 1. Let's say this is simple flesh, and let's say this is fat, Z2. So since both mediums or both materials are different, they have different densities, they have different speed of sound through them, the reflection coefficient goes something like this. That reflected intensity divided by I naught is equal to Z1 minus Z2 divided by Z1 plus Z2 whole square. Right? So if, for example, for the sake of example, if I say that Z1 is equal to Z2, यानी दोनों mediums में densities में कोई फर्क नहीं है, तो ऊपर क्या आ जाएगा numerator? 0. The numerator will have 0. 0 divided by some number is actually 0, which means that when I take I naught over the other side, what does that become? Let's write it down this way. IR equals to I naught into this Z1 minus Z2 divided by Z1 plus Z2 whole square. तो जो ये सारे के सारे ब्रैकेट 0 बन जाएगी, तो रिफ्लेक्टेड इंटेंसिटी क्या होगी? कुछ भी नहीं. इसका मतलब है कि जो आपने इंट्रोड्यूस करवाया था इसमें I naught, वो सारे का सारा ट्रांसमिट हो चुका है एज IT, एंड द रिफ्लेक्शन इज इक्वल टू 0. नथिंग गॉट रिफ्लेक्टेड. ठीक है. And if, for example, there is a difference between them, let's say that Z1 is large or Z2 is large, it doesn't matter. The numerator will not be 0 anymore. If the numerator is not 0, इसका मतलब है कि IR भी 0 नहीं होगा. If IR is not 0, it means that some of the light will be reflected back. तो यही वो बात theoretically है जो आपने यहाँ पे करनी है. ठीक है. That difference between Z1 or the acoustic impedance of medium 1 and medium 2 decide the reflection coefficient, decide what's going to happen. If Z1 is roughly equal to Z2, the reflection becomes equal to 0. And if Z1 is not equal to Z2, or Z1 is greater than Z2, or Z2 is greater than Z1, then IR is not equal to 0, rather IR is closer to 1. So क्योंकि उसने डिस्कस करने के लिए कहा हुआ है, वी आर नॉट सपोज टू गिव अ फाइनल कंक्लूजन, इसलिए हमने दोनों कंडीशंस को डिस्कस कर लेना है इसमें. ठीक है. और उसका लॉजिक आपको मैंने समझा दिया कि वो क्यों हो रहा है. मैथमेटिक्स का मसला है इसमें, फिजिक्स नहीं की. क्वेश्चन नंबर 12, he says, बताएं जी रैंडम क्या होता है. अगेन कॉमन डेफिनेशन. रैंडम मीन्स दैट द रेडियोएक्टिव डिके इज अनप्रेडिक्टेबल. अनप्रेडिक्टेबल क्या चीजें अनप्रेडिक्टेबल है? विच एटम विल डिके हमें नहीं पता, when it will decay हमें नहीं पता. So these are the two things that are unpredictable. Although वैसे एक और चीज भी है, direction of emission of the alpha, beta, gamma radiation कौन सी होगी, that is also unpredictable. Spontaneous का मतलब होता है, spontaneous means that this decay is not affected by the environmental conditions. For example, आपने को केमिकल डाल दिया, एसिड डाल दिया, बेस डाल दिया, उसको हीट अप करने की कोशिश की, उसके ऊपर प्रेशर लगाया. सो फिजिकल कंडीशंस रेडियोएक्टिव डिके के ऊपर कोई पार्ट प्ले नहीं करती. एडिंग केमिकल, प्रोवाइडिंग इट विद हाई हीट, प्रोवाइडिंग इट विद हाई प्रेशर, striking it with something heavy will not change the decay process. So that is why it is called spontaneous. It's happening on its own. We have no control over it. Okay, so the next question is about, okay, so this is ln of A. And this is with respect to time. So I can observe that the system looks something like this. So A is equal to A naught e raised to the minus lambda t. Right? So if I take, क्योंकि उसने खुद natural log लिया हुआ है, तो natural log ही ले लेते हैं. So ln of A equals to ln of A naught minus lambda t ln of E. And we know that ln of E is 1. So this equation comes down to ln of A equals to ln of A naught minus lambda t. And we can see that the gradient is negative as well. But let's make everything subject to the formula. Let's make this to look like something that we're familiar with. So lambda t plus ln of A naught. This is y equals to mx plus c. This is m, which is the negative gradient. This is x, which is, of course, we know that time ही x-axis पे बना हुआ है. And y-axis had a value of ln of A, which is represented here. So before starting the question, I have done a small proof to make sure that this graph makes sense to us. Determine the half-life. एंड ऑफ कोर्स उसने क्या यूज फिगर करें, तो इसमें कुछ थोड़ी बहुत वेरिएशन आ सकती है, कोई ऐसा मसला नहीं है, परेशान नहीं होना आपने. हाफ लाइफ को डिटरमिन कर लेते हैं. इसी सबसे पहले तो हम हाफ लाइफ का फॉर्मूला लिख लेते हैं. वी अंडरस्टैंड दैट द फॉर्मूला फॉर हाफ लाइफ एज रिटन इन द सिलेबस एज वेल इज लैम्डा इक्वल्स टू ln2 divided by t1/2, t half life. Let's replace them. So t half life comes equals to as ln2 divided by lambda. Now lambda क्या है हमारे पास? लैम्डा तो हमारे पास डिके कांस्टेंट है. तो लैम्डा इज डिके कांस्टेंट. क्या हम डिके कांस्टेंट कहीं से निकाल सकते हैं? यस. द ग्रेडियंट ऑफ दिस ग्राफ गिव्स मी द इंफॉर्मेशन ऑफ द डिके कांस्टेंट. सो हम ग्रेडियंट निकालेंगे पहले. सो कोऑर्डिनेट जो मैं पिक कर रहा हूँ वो एक तो ये हो जाएगा, क्योंकि इसका दूसरा जो कोऑर्डिनेट है वो 0 है. सो इट्स कन्वीनियंट मैथमेटिकली स्पीकिंग एटलीस्ट. So this is going to be the first coordinate, और दूसरा coordinate मैं ये pick कर लेता हूँ as 35. Again, picking this is easy. So the coordinates that I have for gradient calculation are going to go something. Please mention the coordinates for the examiner. So they're going to go something like this. So 20, 35. The other coordinate was 0, 36.4. Read the graph carefully. At 0, this is 36.4. Okay. Let's calculate this. So this will be 36.4 minus 35 divided by 0 minus 20. Of course, the gradient will be negative, but we understand that this is also being compared to the negative of lambda. So the negative sign does not matter. The gradient will come out as positive. Comes out as 0.07, but with a unit of per minutes. The decay constant is per minutes. Why is it per minute? Because the graph is also given in minutes. So let's replace this value in this formula, ln2. So lambda is equal to, sorry, we wanted to find half-life, so let's keep half-life as the subject of the formula. Half-life equals to ln2 divided by 0.07. And notice that the question also asks you in terms of minutes. Otherwise, अगर मैं इसको यहीं पे 60 से डिवाइड कर लेता तो हाफ लाइफ मुझे सेकेंड्स में मिलती, जिसको मुझे बाद में मिनट्स में कन्वर्ट करना पड़ता. ठीक है. सो इसको अगर आप डिवाइड करोगे कैलकुलेटर के ऊपर तो आपका आंसर आ जाता है 9.90 minutes, which in the marking scheme is mentioned as 10 minutes. एक ही बात है, राउंड ऑफ ही करना था, प्लस हमें पता है कि एस्टिमेशन ही होती है. ठीक है. दिस पार्ट इज गोइंग टू क्रिएट a little bit of trouble, but no need to worry. He wants us to find out the nucleon number, which according to chemistry is the mass number, right, or the molecular number. So let's figure out. It says at time t0 the mass of the atom is. क्योंकि वो स्टार्टिंग की बात कर रहा है तो अब हमें हर डाटा जो है वो स्टार्टिंग से ही पिक करना पड़ेगा. ठीक है, और एटम ऑफ एक्स ही है ये भी, ठीक है। तो स्टार्टिंग पे हम देख लेते हैं. सो व्हाट्स हैपनिंग एट द स्टार्टिंग पॉइंट, यू सी we have a few equations. So activity is equal to lambda times n, right? We do have the equation that moles n is equal to mass over mr, और mr है जो उसने निकालने के लिए कहा है, ठीक है. mass हमें given है तो moles की जरूरत पड़ेगी. So we need the number of atoms at the beginning. That's why we've written down this equation. एक्टिविटी को यूज करके मुझे नंबर ऑफ एटम्स चाहिए जो शुरू में थे इसके पास, ठीक है. तो अब एक्टिविटी कैसे निकालेंगे, वही स्टैंडर्ड वैल्यू के साथ. हमने ये देख लिया है कि यहाँ पर ये सारा कुछ एल की फॉर्म में गिवन है, ठीक है. सो लेट्स ट्राई टू फिगर दिस आउट. सो आई नो दैट एल एन ऑफ ए इज इक्वल टू, गिवन इन द क्वेश्चन इज 36.4. सो टू फाइंड आउट द वैल्यू ऑफ ए आई नीड टू टेक द एंटी लॉग. सो मुझे एंटी लॉग लेना पड़ेगा. यहाँ से एल खत्म हो जाएगा और ये ई की पावर में आ जाएगा. सो दिस इज गोइंग टू कम आउट एज ई रेज़्ड टू पावर 36.4. So this is my current activity at the beginning of the reaction, ठीक है. Then I will use A equals to lambda n to find out the number of atoms present at that situation. तो वो कैसे निकलेगा? So this is going to be e raised to power 36.4 equals to lambda, which is 0.07. बट इस पे बाद में आते हैं. नंबर ऑफ एटम्स कैसे निकालूंगा? नंबर ऑफ एटम्स तो निकलते हैं मोल्स के साथ. पहले मोल्स आएंगे, मोल्स को अगर मैं एवोगाड्रोस नंबर के साथ मल्टीप्लाई कर दूं तो मुझे नंबर ऑफ एटम्स मिल जाएंगे. सो नंबर ऑफ एटम्स विल बी इक्वल टू मास ओवर एमआर, व्हिच इज 5.66 इनटू 10 raised to power -7 डिवाइडेड बाय एमआर, ये निकालना है मुझे, इनटू एवोगाड्रोस नंबर 6.02 इनटू 10 raised to power 23. ठीक है, ऑलराइट. लेकिन अब एक मसला है, ये जो एक्टिविटी होती है, दिस एक्टिविटी इज मेजर्ड इन बैकरल्स, और बैकरल जो होता है ये यूनिट बताता है हाउ मेनी एटम्स आर डिकेइंग पर सेकेंड. ये टाइम के साथ, पर सेकेंड के साथ है, ये मिनट्स में नहीं होता. तो ये वो मिस्टेक है जो अक्सर बच्चों ने की थी व्हाइल कैलकुलेटिंग दिस आंसर. सो 0.07 शुड बी डिवाइडेड विद 60 सो दैट दिस कन्वर्ट्स फ्रॉम पर मिनट टू सेकेंड्स, बिकॉज जो ए का यूनिट है वो होता ही पर सेकेंड में, ठीक है. तो उसमें डिके कांस्टेंट की गलती नहीं थी, एन की गलती नहीं थी, उसमें ए की रिक्वायरमेंट ही ऐसी है दैट इट इज सपोज्ड टू बी इन पर सेकंड. So this was going to be divided by 60. Now take MR over there and bring E raised to power 36.4 over here. You will find out that this MR is going to come out as 61.8, which will be 62 up to two significant figures. Of course, round up ही किया क्योंकि estimation है हमारी, ठीक है.